Alright, continuing on with continuity, here we have a problem where we're trying to find all values for a, so f of x is continuous. It's a piecewise defined function. So remember, we have 4 different types of discontinuities. We have oscillating that we're never going to see, so we don't have to worry about. We have removable and infinite discontinuities. Those discontinuities specifically come from when you divide by 0. If you look at each of these individual pieces, we have the piece x squared plus x minus 4. That is never going to be dividing by 0 because it's not a fraction. We have ax plus 3. I don't care what a is some number. That's not a fraction either, so you're never going to divide by 0. So we have no jump discontinuities, and we have no infinite discontinuities. Excuse me, we have no removable discontinuities and no infinite discontinuities. However, with a piecewise defined function, we could have a jump discontinuity, and that jump discontinuity could occur at the breakpoint at x equals 2. That's where we change from x squared plus x minus 4 to ax plus 3. We want to force this thing to not be a jump discontinuity. So, in order for this to not be a jump discontinuity, if you look at the last video that I created, we talked about finding a jump discontinuity by looking at the limit as x approaches 2 from the left side and the limit as x approaches 2 from the right side. If we want to avoid a jump discontinuity, then what we need the limit as x approaches 2 from the left of our function to be equal to the limit as x approaches 2 from the right of our function. If that happens, then we will not have a jump discontinuity. If those two are different numbers, then we will have a jump discontinuity. Our goal is to force the issue, figure out what a is, so that these two limits will be the same. So, to figure out the limit as x approaches 2 from the left, well, we look at our function. Our function says f of x equals x squared plus x minus 4 when x is less than 2. What that means is if I'm doing the limit as x approaches 2 from the left, I'm plugging in numbers a little bit less than 2, 1.95, 1.96, 1.97, and I'm looking at that pattern in the table, looking at the y values. I can plug into this function x squared plus x minus 4, and that will tell me, hopefully, what the limit is. And so we're simply going to take 2 and plug it into that function. So we're going to have 2 squared plus 2 minus 4. Whatever that works out to be will be the limit as x approaches 2 from the left. Because again, I'm not plugging 2 into the function. This limit is not asking me to find the value of y at 2. It's asking what the y value is approaching as we plug in numbers that are a little bit less than 2. Same thing with the other piece. The other piece, the limit as x approaches 2 from the right-hand side, means I want to figure out what the y values are approaching as we plug in numbers that are a little bit bigger than 2, 2.04, 2.03, 2.02, 2.01, to see what it's approaching. So we're going to do the exact same thing. We're going to take 2 and plug it in for x. And so that's going to give us a times 2 plus 3. We're trying to figure out what a is, and so we need to force these two pieces to be equal. If we force that issue, if we force the two pieces to be equal, we will have continuity. We won't have a jump at all. So all we're doing is solving a basic algebra equation. 2 squared is 4, plus 2 is 6, minus 4 is 2, so this left side ends up equaling 2. The right side, we have 2a plus 3. Well, that's a very, very easy algebra equation to solve. We can subtract 3 from both sides and then divide by 2. And that tells me that a has to be equal to negative 1/2. If a equals 1/2, then I will have continuity. Because if a equals, negative 1/2. Because if a equals negative 1/2, then the limit as x approaches 2 from the left will equal 2. The limit as x approaches 2 from the right will also equal 2. And therefore those two pieces will meet, and we will not have a jump discontinuity.